We had a little technical difficulty, so I'm going to be doing Bill's portion of the presentation, and then Brian Willis, our technical specialist with regards to controls, is going to be joining us and also doing part of the presentation. Kind of just to do what we call our cold met commercial. This is the cold met facility. We're located in Rockwell, Texas, about an hour east of Dallas, 150,000 square feet. Cold met has been in this building now about 4 years. It's a great show place, always an open invitation. If you've not visited the facility, we certainly would like to invite you there. We have a nice conference facility, and then all our corporate headquarters and manufacturing is done here. Cold met business is really structured into 3 main business segments. We have our core catalog equipment, we have our EP or engineered projects, and then we have the RP filtration products. When we talk about the core catalog equipment, here we're talking about basically, our catalog that we have, and we have a wide variety of different booths, everything to benchtop booths to IBs to, standard booths for large equipment. And then we have our batch ovens, which will be really the focus of what we're going to talk about today. And then we also have a wide variety of different powder booths, basic to more advanced for process type automated systems. When we talk about the engineered project side of the business, here we're talking about much larger format booths. Probably the largest booth that Cold Met's built, we think the largest booth in North America, the one that's in the Gulf Coast there for Kiewit, doing sections of those oil derricks you see. Also within the EP group, we do process washers. You can see here a 7-stage and a 3-stage washer, as well as process ovens, larger booths, and again, specialized components that we can provide through our integration partners. And then the third part of our business is the RP filtration business. Cold Met acquired this business in 2017. We spent 2018 integrating this business into the facility, and then 2019 and 20 has been focused on growth. Cold Met is the only spray booth manufacturer that actually also manufactures their own spray booth filters. Because we know the quality of the filters, we know the quality of our booth, we can offer our 5-year program, and I'm sure a lot of you have heard about our W-Series filters and our W-Series program. If you haven't, reach out and we'll fill you in on that. So today, the presentation overview is really focused on batch oven optimization. We're just going to do a quick review on the BO and VHD style ovens that we offer. We did do a more detailed presentation on those ovens. I believe it was a week or 2 ago, and that's available on our website or on our YouTube channel. We're going to talk about catalog versus process-specific ovens. We're going to get into some of the details. Well, Brian will about air versus part temperature, talk a little bit more about the controls and some of the new products we have that allow you to optimize and really understand what's going on with the oven. And then we'll just look at a couple oven enhancements, and then we'll wrap it up from there. So just a quick review, Cold Met curing solutions. Again, today we're specifically going to talk about our batch oven, and we have the 2 configurations, the BO, the VHD, the Vortex oven, but we also make batch cure chambers. Typically a batch cure chamber, we see them used for woods or plastics, maybe where they're using 2-component materials and they want to accelerate the cure. A lot of them, again, used in the wood industry where they might put a sealer down. They want that to dry up. They can sand it, do multiple coats, and just speed up the process. We also do the process ovens. You can see one here in the lower right-hand corner. And this happens to be a large elevated oven used on a conveyorized system. And again, that type of product falls under our EP group. And then, although it's not a big part of our business, we also do electric batch ovens. Depending on customer's process, we have one in particular where they're putting a hard coat on Lexan sheets, and they don't want a lot of air movement. They don't want a lot of, combustion residue. So an electric oven was a great solution. So if you have an opportunity for an electric oven or a process oven, a batch cure chamber, let us know and we can help you with those. Batch ovens, just a quick overview to kind of calibrate our terminology. Batch ovens are used in lower volume manufacturing processes to essentially process batches of parts. A lot of times a small company might start out because they don't need an automated line. Again, they can buy a batch oven. if their business grows, then they can buy a second oven. So, one way to increase capacity with the batch system is just to have multiple ovens, or maybe one to use the dry off and one to use for cured. With batch ovens, typically, we want to know how the parts are being transported. Is it going to be manually? Is it going to be on a cart or an overhead rail or crane? This is also going to be very important when we talk about process-specific ovens, because when we're designing a process-specific oven, we really need to take into consideration and understand all the components that are in the oven that we're trying to heat up. So again, batch ovens can be used to cure liquid or powder coatings. Also, they may be used sometimes to dry parts or maybe gel powder if it's a multi-stage powder application. So typical process utilizing a batch system, it might be as simple as a clean, a coat, cure. And in some cases, maybe it's somebody that just has a small business doing motorcycle frames and rims, and maybe they clean the part by manually wiping it in the same booth that they're putting powder or liquid coating on. Then they need the oven to cure it. It could be a little larger where they actually have, as we're showing here, a dedicated clean booth. Then they go in the oven to dry the part, powder booth to coat it, back in to cure it. If they want to speed up their process, then they might want to have a dry off and a cure oven. So again, a batch system, there's no set rule, but again, it's just used to process parts in batches. When we talk about our BO or our standard batch oven, just to identify really how this is different than the VHD oven. The main difference is that we have the ductwork in the sidewalls of the oven. So we get more of a cross draft through this oven. And so this is a great solution for a wide variety of parts. And also if you have more complex parts, the side ductwork with the H nozzle allows you to adjust and somewhat balance that airflow. One thing that Coleman always has is dedicated exhaust fans. And we're going to look at a little comparison chart, but all of our ovens are considered Class A, which means the Class A oven, you could have some hazardous vapors in there that could be, or I should say, volatile vapors. So again, those are some of the unique features. Now with our batch oven too, we have a fully assembled burner box that gets pre-tested and shipped out. Again, we make all of our own oven panels. So once you order an oven, it's a function of just assembling it. When you look at some of the competitive ovens out there, some of the internet ovens, the customer actually has to build the oven panels themselves and put the insulation. So there could be days spent just trying to put the oven components together before you can actually construct the oven. But again, main differentiator with our batch oven, the BO series, is the ductwork in the side. When you look at our VHD oven, here we have the ductwork or the discharge ductwork in the ceiling of the booth. Really the whole thing behind the VHD oven was to have a more cost-effective, competitive oven out there. And so typically you might see that this oven will come in maybe around 6 to 10% lower than standard BO oven. And it's because really just the design of the ductwork, it also has a little bit narrower footprint, not having ductwork in the sidewalls. For this unit though, there is some assembly required on the burner enclosure. Basically the burner comes mounted and pre-tested on a frame, then you just have to install the panels on it. But other than that, the two ovens are very similar. Many of the same features as far as temperature range. Mainly the differences when you look at these are the options on where the heater box can be located. With the BO oven, since the ductwork is in the side, we have more flexibility on where we can locate the heater box. Now, in some instances, it really doesn't matter where the heater box is, but others, if there's issues with floor space or access based on some obstruction, then it might be a critical consideration. With the VHD oven, the heater box has to be on the side or at the back. Again, we talked about the difference with the ductwork, and then because of the ductwork, it's the airflow. So with the BO oven, we have side discharge, with the VH down discharge. But other than that, as far as the burner, the controls, everything is the same. If you have a situation where to handle the parts, you need an overhead rail, then your option would be to go with the BO oven because there's no ductwork up there, so we could manage that. Both ovens come standard with our smart control panel. In addition to that, they also come with the Smart Connect app, and they have an option for our Smart Batch. Now, I'm not going to dig into the controls too much because Brian's going to touch base on that in more detail here shortly. So really the crux of this presentation was to get to this point to talk about a catalog versus process specific ovens. So with the catalog oven, basically these ovens are pre-engineered to meet a wide range of general conditions. And you can see if you look on the back of our VHD or batch oven literature, there's a wide variety of different ones that are pre-configured and engineered that'll meet specific needs. In order to get you a quote on these, all we need to know is the size of the oven. We talked in that other presentations, I referenced how to size an oven. We need to know the fuel source, whether it's natural gas or propane. We need to know, how are the parts going to be moved in and out of the oven? Do you want single front double doors? Do you want what we call pass-through oven, where you have dual doors? What type of door? So we have a variety of different doors available. And then we need to know the roof height of the building that it's going to be in so we can quote the exhaust stack. So here's a couple examples of pre-engineered ovens. So you can see whether it's the BO or the VHD oven, they are similarly sized. They both have a 1 million BTU burner assembly. And again, both will be effective. Now these units, again, as I mentioned, were pre-engineered. So we do some calculations based on, general part and loading. And that's how these are designed. So if you have some lighter weight parts, or you have motorcycle frames, or maybe you have a couple heavier parts, these ovens are going to be great. But if you buy this oven as a catalog pre-engineered oven and you load it up with 30 forklift weights made out of cast iron, it may take longer for you to get up to temperature because the burner could potentially be undersized. So that's where we start talking about process-specific ovens. And so these are ovens that are designed to meet specific needs of the process. So a lot of the information we need that's kind of grayed out here is still the same. We need to know all that, but really the additional information that we need to make a process-specific oven, to engineer it specifically, we need to know information about the part. First of all, what's the size and the weight of the part? Then we need to know what the substrate is. Is it aluminum? Is it steel, cast iron? Is it copper, brass? What is it made of? That'll allow us to look up the density, and we'll see that on the next slide. I mentioned this a little bit earlier, but we also need to know, what other items are going to be in that oven. These parts are going to be on a cart. Are you going to have 20 small parts on a large cart that's put in the oven? Do you have a large I-beam overhead that we need to account for as far as, energy? And then also it's good to know whether it's a powder or liquid coating. The reason we need to know that is, alluded to here. So based on that additional information, then we will actually come up with a process specific, or we'll engineer an oven that will operate very efficiently for those specific requirements. And so once we know, what the material is, we can look at what the specific heat capacity of that material is. So you can see whether it's plastic, wood, typically we're going to be more looking at aluminum, mild steel, cast iron, or brass. We can look at what the specific heat is. And really what this is defined as is the heat required to raise the temperature of a mass of a given substance by 1 degree. So by knowing the total mass and also knowing what the substrate, we can calculate what the BTU of that oven needs to be and size the burner appropriately, so that if you are going to do, 50 forklift weights in there, we're going to make sure that, you're not spending all day trying to get them up to temperature. We're going to size the burner appropriately, and that way you can cure them in, the desired amount of time. Another thing that we can design the oven specifically for is the number of air changes. And when you look at different types of ovens or different coatings, there are some guidelines. So if we're building or designing a dry-off oven, we're going to design it to have 6 to 10 air changes. If it's an oven for curing liquid coatings, where we have more volatiles in there, and we want more air movement, again, we want to go in that 6 to 10 air change range. If it's a powder oven, we don't want a lot of air movement that's going to disturb or maybe blow the powder off the parts. And so with a powder oven, we're going to design the air changes to be around 3 to 5. If we go back and talk about our catalog ovens, those are typically designed at 6 air changes. And so if we know you're going to be curing powder, we can run it through our calculator and design the oven again specifically for your needs. And again, other considerations, so those are guidelines, but if you have lighter weight parts that may blow around, then that's going to, point us in a certain direction. Or if you have heavier parts, that would allow us to have more air changes. So again, by knowing the details, the specific details, we can design an oven that's going to operate very efficiently and use less energy overall. All right, at this point, I'm going to turn it over to Brian and let him talk to you about our oven controls and some options that we have there to optimize an oven.
Thanks, John. So the controls for a BO and a VHD oven, from an operator's point of view, are pretty similar. I guess the biggest difference would be that on a VHD oven, the touchscreen is actually mounted in the door of the control panel, and that control panel is attached to the back of the oven. And on a BO oven, the touchscreen would shift loose, and it can kind of be installed pretty much wherever is convenient for the operator. Our control panels are designed and built in-house in our UL 508 panel shop. And the big benefit to that is quality control. We're able to deliver a consistent end product every time. The panel shop is inspected about 4 times a year by UL and ETL, just to make sure we're meeting the standards. We use high quality components like Hoffman enclosures, Omron PLCs, Winetech touchscreens, and we do our own programming. So that gives us the ability to customize our menus specifically to our equipment and make it as simple as possible for an operator. We also design it with some multi-level passcode protection, and that kind of helps prevent unauthorized changes to the batch times and the temperatures and shutdown procedures, things of that nature. So we include built-in diagnostic and troubleshooting guides. This has some photos in there that not only helps out with the initial startup, showing you how to change fan rotation if necessary, but it also kind of helps out with some of the more common faults that we see, as the oven ages. And then the screen also has a built-in VNC server, which allows for remote access if it's connected to your local area network. So this year we introduced the Smart Connect app. It's available for download to your Android, PC, or Apple device. And the app basically allows you to view all the critical information about the oven, like the burner status, the oven temperature, and maybe the batch time remaining. It includes some built-in hour meters, so you know how long the devices have been running in the oven. And that's nice because it basically lets your maintenance department know, how long it's been since a belt was adjusted or a bearing was greased. Also has an operation log, and it records time and temperature as well. It does that anytime the fans are running, so you can kind of see the curve as the temperature comes up and then comes back down whenever the fans shut off. The app is free. It comes with a 1-year subscription for the email notifications. And the notifications can be set up to send to people within your organization. Some of the alerts would be maybe when a batch is complete, or if the oven isn't in the correct temperature range, maybe if it's running too hot or too cool. And you can actually configure these email alerts into different groups. So, maybe the maintenance alerts for how long a device has been running would just go to the maintenance department, and the batch or cycle complete alerts could go to a shift manager or something like that. Next slide, John, please. All right, air temperature versus part temperature. So wanted to kind of explain some key points with curing powder. Various powders are going to cure at various temperatures, and they're all, a little bit different. They have a cure schedule, which is kind of shown on that graph over on the right-hand side of this slide. And basically, the graph is going to show you that it needs to be at a specific temperature for a specific amount of time. And you'll notice on the graph, the higher the temperature, the shorter duration of the cure cycle. So, for example, if you're running at 300 degrees, you would have to cure the part for maybe 30 minutes. But if you run the temperature on up to 425, then it looks like it would only need about 18 minutes or so to cure the powder. So the trick there is you don't want to, you think you could just set it as high as possible and then let it run, but what you end up doing there is you can possibly overbake the powder. So you have to keep that in mind too when you're doing your temperature set point. Now, with a standard oven control panel, the controller doesn't really know what the part temperature is. It's looking at the air temperature. And this graph is actually talking about part temperature. It's not talking about air temperature. So you kind of need to know what your part temperature really is. Whenever you set the oven controller for 400 degrees, it's basically going to look at the air temperature, bring the oven up to 400 and kind of hold it there. And what you would typically see is that the part temperature would kind of lag behind that, due to the mass. The parts are usually thicker, and the heavier the part, the longer it's going to take to come up to temperature. So a lot of times what you do is you'd set the oven for a little bit higher temperature than what you actually need. So if you're looking for 400 degrees, you might set it for 415 or 420. But you still don't really know for sure what the actual part temperature is unless you have some kind of device that can track that temperature. A big name in this department would be DataPack. There's some others out there, but basically what that is they have a box that can hang inside the oven that has some thermocouples that are magnetic, and you put these thermocouples on the parts, and then you turn the oven on, let it come up to temperature, hold the set point, and then cool down. And then at the end, you take the box out, hook it up to your computer, and you download the data. A lot of people don't have access to a device like this. It's actually quite expensive. So another way that people will do it is they'll take maybe a temperature gun, like a handheld infrared or thermal imaging gun. They're less expensive, but they're also less accurate. And depending on the distance to the part and the reflectivity and things of that nature, you can easily see temperature swings on the same part. If you measure it at the top or the bottom or the side, you could have a 20-degree temperature difference just depending on how far away it is. So usually what happens is, an operator would just set the temperature higher and set the batch longer and just, let it run to make sure that it gets to the required temperature, which works. May not be the best, most cost efficient way to do it, but it does get the job done. Higher temperatures for longer periods of time means you're going to use more fuel, so you're using more money. And then, longer batch times means less batches per day, so you're getting less production done. And then, if the operator sets it too high, you could have overcured parts, which, can present immediate issues where you have to rework it. Could also be some long-term issues where you end up with your parts coming back under warranty because, the coating failed 6 months down the road. So not really the best way to go about it. So our solution to that, which we released this year, is Smart Batch, and it's an optional upgrade to the controls. And what it does is uses magnetic thermocouples that are inside the oven, and they plug into a junction box mounted, to the wall on the inside of the oven. That's convenient because if you don't need the probes, during the day, you can disconnect them and not have to cycle through the heat. It's also, you're not having to run probes along the floor where it's a trip hazard or where they could get damaged by a door opening and closing on them. So it allows for up to 4 thermocouples, and what it does is it's going to display the temperature of those parts live on the touchscreen. So it does several things for you. The first thing is you're able to know for sure right off the bat if the parts actually reach the temperature. You're also able to make real-time adjustments if you need to. So if you're watching the temperature and you've got 11 minutes left in the batch, but you need to run 15 minutes and your part temperature is not quite there, you can just extend the batch to make up that difference. Another cool feature is you can actually just let the system control the batch for you. So you can have it set up so that the batch timer doesn't start until the part temperature is actually reached. All of the temperatures are also recorded. Every 60 seconds, it takes a snapshot and stores that in the touchscreen. And then you can take that data and you can export it with the USB port that's on the screen. Or you could also have it emailed with our Smart Connect app. So every time the batch is complete, it'll just send out a little email showing you the temperature and time report. So the system, it comes with the wiring and the junction box and the plug and everything. And then you can also purchase, additional 32-foot extension cables if you need to get further into the oven. So I just wanted to cover a few of the most common items to see that can lead to downtime, which costs you money. So the Smart Connect app has the built-in feature that monitors the devices, as I mentioned earlier. And whenever a device is nearing a maintenance point, it'll just send you an email. And remember, you can set up groups so that those emails will just go to a maintenance department. That way you're not getting bombarded to a plant manager that may not really care about a belt that needs to be tensioned or anything like that. But some of the most common things that we see that can shut an oven down is a dirty UV scanner, clogged flow switch, fan wheel on the combustion blower, incorrect belt tension, and then bearing failures due to lack of lubrication. Another common thing we see, I guess you wouldn't really necessarily call it common, but we do see it on occasion. Poor housekeeping. People forget about the stuff that they can't see. So the things on top of the oven, if it's out of sight, out of mind kind of deal. But it's important to get up there and occasionally clean that stuff up. Maybe whenever you're up there adjusting belt tension, take a broom and a shot vac up there. Just don't leave it up there like the picture shows there on the right. But it's especially important to keep the area around the burner clean, because if the blower wheel gets dirty and starts pulling in dust and powder and things of that nature, it's eventually going to clog up the burner, and that just leads to more fuel consumption. And, once the burner gets to the point of no return, it basically has to be replaced. So that gets, pretty expensive. One way to kind of help reduce that is to actually duct the combustion blower outside of the building. Just keep in mind that if you do that, you want to make sure that the duct is bigger than the inlet, and just try to keep the turns to a minimum, because you don't want to restrict the blower by adding additional static pressure. It's also a good idea to occasionally take a look at the flame inside the oven. You can either do that by looking through the sight hole on the heater box, or if you have the door open and it's at high fire, you can pretty easily see the flame in most cases. And what you want to see is mostly blue with some yellow-orange tips, kind of like what you see on the blue portion of the pictures. But what you don't want to see is the bright yellow or a long lazy flame that could be lapping back around and touching the metal and stuff around the burner shroud. That's kind of what's shown there on the yellow pictures. So if the flame looks, bright and yellow like what we saw previously, it typically means that you don't have the proper air to fuel ratio. And normally that means that it's not getting enough air, because the gas is pretty much preset. It just modulates the gas up and down. But, if the combustion blower wheel gets dirty, or if powder gets pulled in and starts clogging up the mixing wings, and what you have is not enough air pressure across the burner, but you still have the same amount of fuel that you had coming in. So it kind of causes the burner to go fuel rich. And that eventually leads to, cracked mixing wings and gasket failures and heater box deterioration and higher fuel bills, because basically if the burner's not running optimally, you're going to be using more fuel to get the same BTUs. So some of the first things you'd want to check is the combustion air, clean out the blower wheel, and you might even use a welding tip cleaner or something like that to clean out the holes in the mixing wings. But really the only way to know for sure what's going on is to, connect a manometer to the test ports on the burner. And manometer sounds complicated and expensive, but it's not. It's just basically a pressure gauge that reads really low pressure. And we're talking less than 1 PSI. So what you'd want to see is about 1 inch water column across the burner for air, and then between 5 and 8 inches water column for the fuel pressure, at high fire. And we have some detailed instructions on, how to connect that and adjust the pressures if you need to. You can just, contact us on our website, colnetsb.com, for more info. But I'll go ahead and turn it back over to John. He's going to discuss some of the new auto seal door options that are available for both FIO and VHD ovens.
All right. Thank you, Brian. As we talk about optimizing the performance of the oven, Brian talked about the Smart Connect, which is a standard feature that can give you alerts and notifications, and then Smart Batch, which is an upgrade or an enhancement, but that will allow you to measure actual part temperature and actually operate the oven off of those probes. And so what that will do is, one, it'll ensure that you're getting the proper part temperature for the proper time, which means you're going to get a good quality cure. One of the other new products we introduced, which is an upgrade to the oven, is the auto seal roll-up door. And really the biggest benefit of this is the sealing capability. So the auto seal door uses a patented seal on the two sides. When you look at a traditional door, typically when it's first installed, you get great sealing, but over time, as the gasketing wears, as you can see in these pictures, you get a lot of heat loss around the doors. And then also, one of the other things with a traditional oven door is as you open it, you get that blast of heat out. So with the auto seal door, really the primary we have to are concerned with sealing is at the bottom of the door. And even if you have an uneven floor, the door is actually self-leveling. There's a flap on the back that comes down, and then the pressure within the oven actually pushes that tighter to the floor. So again, you get a tight seal there as well. Overall, in addition to the seal, you also have reduced footprint. So if you have a large batch oven with large dual doors, those take up a lot of area in front of the oven. So a benefit here is that you can free up an aisleway or that extra space. The other thing is that this door will operate just like the garage door on your home. It can be opened or operated remotely. So if you have a person loading parts into the oven with a forklift, they don't need a second person opening the doors for them, or they don't have to get off the forklift to open it. They can do it remotely, and so that's going to improve productivity. Also, with the improved sealing, we see typically a 10 to 20% energy savings just by reducing or eliminating the leakage. Another feature is the variable door height. So in some cases, if you have a very large oven, you don't always need to open the door fully and allow all that heat to escape. So again, that ties back to more energy savings. Typically, when somebody utilizes either in a retrofit or on a new oven application the auto seal door, they're able to process more batches per day, typically at least one more, if not more than that, based on the efficiency. And also it eliminates issues with oven door warpage, or if you have issues with the floor over time. So again, it's a great enhancement, and again, it is available as a retrofit. Literature on everything we talked about as far as our batch ovens, the BHD, I briefly mentioned the batch cure chamber, but the Smart Connect, Smart Batch, in addition to auto seals, all available on our website. We also have a range of YouTube videos, a range of content that we've been putting out. One thing that we've done is we've recorded, this is now our 12th webinar that we did. All of them have been recorded and are available on our YouTube channel. You can access them also through our website. We've also done a series of small video clips. So here you can see Brian talk about the Smart Connect oven interface. We also have more details on Smart Batch. Luke has done one on LED lighting. We probably have way too many of Trey Peavy on there, but Trey's done a lot of good ones with Casey on filter installation, different accessories that we have to improve the filter install. So would encourage you to check those out. At this point, we'd like to take any questions that there might be.
All right, John, we do have a few questions, but before we have people logging off here, I just wanted to mention that don't forget to download the handout. They're on your control panel. All you do is simply download it before the presentation's over so you can have a copy of this presentation for reference. And so now, John, I'm going to get to some questions here. Our first question is let's see, how tall is the burner box when on top of the oven?
Well, I'd have to look specifically to get that information. It's a great question. I can try and see if I can quickly refer back to another slide. Maybe a little cheat here. So if we looked at the BO with the top mount, the height is 14'4". So the height of the burner box is about 4 foot that it adds. About 4 to 5 feet, 5 feet.
All right.
But
Thank
if
you,
you have
John.
a specific version, we can get you the exact answer, or you could reference the literature.
Very good. Thank you, John. Now, this next question, I'm hoping I'm interpreting it correctly, so this one may take a little time. Can you please talk just a little bit about the efficiency of a preheated system in the oven cure?
Brian, I don't know. Do you have a? I'm not really familiar with what that is asking.
Yeah, I'm not. What was the question again? I didn't really understand what that was.
Let's see. Let me read that to you again. They're just kind of wondering a little bit more about the efficiency of a preheated oven in the oven cure process. And I hope I'm just reading it right out there, so I'm not sure. Maybe
Okay.
we could ask for a little clarification from the gentleman who wrote that. If you could just give us a little more clarification, we'll go on to the next question and see if he can type in a little bit of more detail about what he's asking for.
If not, maybe detail or reach out to us directly via email.
Yep, I will be able to respond later because I do have the person who asked it. I can see their email address, so we can send them more detailed information. But
yeah,
going on.
The question might be that he's asking if the oven is already at temperature and the parts are pulled in and out throughout the day rather than running a full cycle and allowing it to cool down each time. And generally that would be a more efficient way to run the oven. If you have the capacity to do that in your shop, you can have the oven at a set point temperature all day long, bring the parts in and out rather than waiting for the cycle to complete. So that would make the oven more efficient from a production point of view.
Okay, that's good, Brian. Thank you. I appreciate your help on that. Another question here, can the smart batch be added to an oven from a different manufacturer? So can it be added to a competitive oven?
So the smart batch wouldn't really work well with a competitor's oven. What we would most likely have to do there is actually supply just a heater box with a burner and a control panel and everything on it. That way we know that the way we control the burner and the fans and everything is done basically in house, and we're able to test it before it ships out, and then it shows up kind of as a kit that could be just put up against an existing oven, and then it would be monitored controls with the correct burner size and fan horsepowers and all of that thing.
Okay. A couple more questions here, gentlemen. Thank you for all your help. Can the auto seal door be used to retrofit onto a competitive oven?
Yeah, great question. Yes, the auto seal door can be retrofitted pretty much on any oven. We basically just need a flat surface to mount to. Typically, we'd like to see 12 inches on each side, 18 inches overhead. If that was not available, we could probably fabricate some panels or an adapter to make that happen. What I would say is if you have an opportunity, get some pictures and some measurements and contact us and we'll help you work through it.
All right, thank you. Another one here, what are the factors that make the flame change colors? Does that have anything to do with a bad installation?
So the flame changing color mainly comes down to air and fuel mix ratio. And from an installation point of view, it would just have to do if the burner was properly set up during startup. Whenever we test them here at Coleman, we run them on 5 psi of gas pressure and do our testing without the entire oven as a whole. We're just testing the heater box. So once it gets out in the field, you kind of have to do a little bit of fine tuning based on the gas pressure that you have in the field and also the oven chamber pressure, if the exhaust fan is pulling a little bit of a negative or things of that nature. So, usually just having the manometer hooked up to it in the field is the best, most accurate way to get the flame color where it needs to be.
All righty. Thank you, Brian. And we have one more question is that you mentioned the Smart Connect comes with magnetic thermocouples. What do I do if my parts are aluminum?
Yeah, so there's other probe options available. Some of them would be like a clamp style thermocouple. And then there's also a ring style thermocouple where you could put a bolt through it and bolt it to a part as well. So there's a few options to get a good surface temperature reading besides magnetic.
All right, thank you. And I believe that's all the questions that we have. Could we advance to the next slide, please? In this handout, as I mentioned, it is available as a PDF. You will get a copy of the who to call list, you know, a map kind of showing who is the rep for your territory, as well as all their contact information. The next slide, please. We also mentioned, John showed that there is a lot of literature that represents a lot of the different products they talked about today. All that is available on the Colmet website. So colmetsb.com is your resource for all that information. Next slide, please. We mentioned that please watch your email the next day or two. You'll see the next mailing going out with the next 2 webinars that we'll be holding. So please look for that email. And then next slide, please. They also mentioned, as much as all these webinars we've been doing, John mentioned we've done 12 so far, plus, you know, all these other videos that they've done as support materials. We have a lot of stuff on our YouTube channel now, so please don't forget to check that out. It's a good resource tool. Also wanted to mention that when you get about an hour from now, after this presentation ends, you will get an email that'll come out and thank you for attending the webinar. On that is a certificate that you can download, that certificate of attendance for today's webinar if you want to put that in your file. So make sure that you grab that and download that from the email. And I think, let's see, no other questions have come in. So we do appreciate your attendance today, and this will conclude our webinar. Thank you again for attending.